Atoms are the most basic units of matter that determine chemical structure, but it took centuries of study to discover the model we know today. The first person to experimentally prove the existence of the atom was John Dalton in the early 1800s. He suggested the billiard ball model, in which solid sphere atoms combined when they collided in whole number ratios to form molecules and compounds. This model didn't include subatomic particles, which would later be discovered. Later in the 1800s, J.J. Thomson did experiments that introduced a new atomic theory. His experiments with cathode rays showed the presence of electrons in the atom. From this, Thomson came up with what is called the plum pudding model. Negatively charged electrons existed in positively charged matter. Thomson proved the existence of the first subatomic particles, the electron, paving the way for the discovery of the others. Both scientists believed atoms were solid throughout and there was no empty space. Ernest Rutherford developed the nuclear model of the atom. He conducted a gold foil experiment in which he fired alpha particles at gold foil. Only some particles were deflected. He could conclude that there was a dense center to the atom, known as the nucleus. The nucleus was surrounded by empty space. Niels Bohr. Niels?
How to pronounce this word? Niels.
Niels Bohr later utilized earlier work by Max Planck to create a model of the atom that followed early quantum theory. They proposed that energy is quantized and that atoms exist in orbitals. This model put electrons in shells orbiting the atom, and it was used to explain light emission. In the 1930s, Erwin Schrödinger and Warren Heisenberg disapproved of the Bohr model for all elements other than hydrogen. They came up with the quantum mechanical model. This model said that electrons exist in 3D orbitals. Heisenberg's uncertainty principle said that within these orbitals, the exact location of an electron could not be found, and that these regions were regions of probability. That's the story of the atom.